Hi, my name is Elena. I am a developer experience engineer at Miro, and in this video we're going to be talking about diagramming and how you can bring your diagrams to Miro board using the Developer Platform API. This video will have 3 parts. In part 1, we're going to be looking at basic shapes and how we can connect them using Developer Platform API. If you're already familiar with Miro Developer Platform, feel free to skip to the next section. In part 2, we're going to take a list of tasks that depend on each other and try to represent the relationship between them on a Miro board. In part 3, we're going to be looking at some more advanced topics like topological sort that will help you move beyond our example. Okay, let's get started. In this video, we are not going to create a Miro app. If you don't have one yet, check the link in the description below, and it's only going to take you a couple of minutes and then we can get started. Since I'm using a sample app with some pre-generated code, I'm going to delete all of the code that is creating a sticky note because we are not going to be needing this anymore. In the app file, we're not going to make a lot of changes. We're going to bring a button that will allow us to trigger the function in another file. So let's head to our draw file. We are going to start by creating 2 shapes and connecting them together. Let's create the first shape. We are specifying the position and the type of a shape here, but we are using the default width, height, and any other parameter. Let's check how our app is working. Okay, we've created a shape. Great. Let's add a second shape. It's exactly the same code, except we don't want it to be created in the same position, so we're adding an offset. And we have 2 shapes created, so let's connect them. And the connect function will call the create connector Miro function. We're going to choose the elbow shaped because I just like it more. Then we're going to have the start and the end parameter with the IDs of the shapes. Perfect. We have created 2 shapes and connected them. Let's move on to the next part. It's time to actually bring our tasks to the board. Let's take a look at our list of tasks first. We are building a rocket ship, and to do that, we need to get funding and hire some engineers. Let's go to our draw file. I removed the execution because we don't want to create the shapes that are hard-coded anymore, but we do still need to use the connect method, so it stays. We're going to load the tasks from the JSON function that's going to do that, and we're just going to read the payload from the JSON file. But since the tasks in the JSON file are referenced by IDs, it would be very convenient to replace the IDs with the reference to the actual tasks. We're going to create a map with task ID to the task. That's going to help us to associate all the tasks by IDs. Now that we've loaded the task, we can start creating shapes. We're going to start by defining the default position, and we're going to iterate through the whole list of tasks, and for each task, we're going to draw the task. Let's create a draw function. After we have created a task, let's adjust the position a bit so they are not jammed together. The X coordinate stays the same, and the Y is using the same offset as we said before. Let's create a map of the tasks that are already created, so we're not creating the same task twice. And of course, we'll need to clean the created map. If the item is already in the map, we're going to return. Let's draw the actual shape. It's going to be using the same method that we used in part 1, but instead of hard coding X and Y, we're going to pass the position that we used as a parameter in the function. We're going to add this task to the created map if the task is blocked by any of other tasks. We are going to iterate through the list of the blocked tasks, and we're going to connect them together. Of course, before we connect them, we need to check if it indeed was actually already created, and if not, we'll have to draw it first. So let's call the draw function. First of all, we're going to adjust the vertical position of the shape. We can use the same offset, or maybe you can play with any other one to see what works better. Now let's calculate the array of positions where we can place our dependencies. If we have an array that has predefined position for every one of our dependencies, we can pop values from this array and pass it to the draw function. Let's calculate the positions. If we have only one dependency, then of course we can use the current position, but what if we have more? Let's head to our Miro board to see how it can look like. Imagine this is our root node with its dependencies. The vertical coordinates are the same for all dependencies, but the horizontal, the x coordinates, are basically offset multiplied by some coefficient. For the central dependency, the coefficient would be 0, and for the left bars, the coefficient would be negative. There are multiple ways to calculate this coefficient. I just went with selecting the middle of the array and adjusting for 0 being a starting index. Now that we have our coefficient, we can go ahead and calculate the positions. For each dependency, we're going to push a new position and we're going to build it by updating the x value to the current position adjusted by our coefficient multiplied by an offset. It can be the same offset as before or a new one depending on how you want your diagram to look. And of course, the vertical position stays the same. Don't forget to increase your coefficient as well. Now let's head to our app and check if it's working correctly. We took our task from the JSON and represented them on the Miro board. Alright, we put our data as a diagram on a Miro board. You can clearly see connection between the tasks and you can reuse this for any other graph you have. Or can you? The tasks are not sorted. Dependencies can appear before the actual task that depend on them. To work with a list of tasks like this, we will need to apply some kind of sorting first. We need to hire engineers before we can build the rocket ship, which means that even if we put hire engineers, even if we put our hiring task higher in the JSON, it would not matter after we apply the sort because building the rocket ship will be the first in the sorted list. Let's take a look at how it's going to work. So our main task, the one that's supposed to be on top of our diagram, is right here. To make it more clear, we have those items represented on the Miro board in the same order as they are in the file. So let's take a look how topological sort will work. Let's build a sort. So first of all, we're going to call the function and we're going to create the same function. Inside, let's prepare an array of sorted tasks that we're going to return. For each of the unsorted tasks, we're going to call the function called visit. Each time we visit a task, we're going to mark it as visited. So let's add a set that's going to store them, the return if the task was visited, and add the task to the visited set. All right. When we go into the task, let's say we're here, we marked it as visited. We check if the task has some dependencies, if the task is blocked by other tasks. On the Miro board, we can see that there is an arrow that goes to find a budget node. In our code, if we have blocked tasks, we're going to visit that node. And as soon as we go to visit, we mark it as visited. Then we check if this node has any blocked task. And it does, we mark this one as visited. This node doesn't have any dependencies, so now we can add it to the stack. Let's add this code. So call investors would be the first node in our stack. Let's mark it as green. But then we go back up the stack and this node is going here. And then this node is also going here. We return to our original array and we have a new task that we're going to mark as visited. This task also doesn't have any dependencies, so it goes straight away to our sorted stack. Then we have the next one. We are visiting, it has a dependency, but this dependency is already visited, so we're skipping it. But we have a new dependency that we're going to mark as visited. This dependency doesn't have any other ones in the blocked by list, so it goes to the stack. Now this one can go to the stack, and we have the last node left, which is building a rocket ship. So we added the last item to the stack. We can mark it as green, Now we're going from the task with least amount of dependencies to the task with the most amount of dependencies. And this is not exactly how we want to represent our tasks because we want to see the big picture first. Let's reverse it. If we represent this graph differently to see our dependencies better, you can see that there is not a single arrow that goes up. All the arrows go down. For any task in this list, we can be sure that all of the dependencies are going to be below. This way, we sorted the very mixed up and difficult list to the same state as our first list, and we can apply our algorithms again. Let's check how the app is working. Let me find the app. Here you go. This is our final diagram. All right. In this video, we learned how to create shapes, how to connect them to each other, how to position them on the board, and how to build more complex solutions to build real problems in a visual format. Don't forget to like this video if you enjoyed it, subscribe to the channel, and let us know in the comments below if you want some other topics to be covered as well. Thank you for watching, and I'll see you in the next one.